All right, ladies and gentlemen, we're going to try to record our first video here today. Last night's didn't work, so we're trying again. What you're going to do is in your notebook today, you should have set up everything from your notebook video. If you have not watched that video yet, please go in and watch the video that says notebook and homework. So my notebook looks like this. I'm going to be following along with you guys this year because it's my first year teaching this class. The very first page, if you're an A-Day student or a DLI student, you should leave that page blank because you're going to glue in your table of contents. This table of contents is a full-size document. It looks like this. If you're an A-Day student, you'll receive this paper on Monday. If you're a DLI student, you can access the PDF and print it out if you have a printer. If you don't have a printer, you can copy down the skills and numbers so that you can write down the assignments as they are assigned. What you're going to do is you're going to fold along this middle line here, and then it's going to sandwich around, give a hug to that first page. What that looks like then is, so you'll see the little comic and algebra skills, the title of the unit. And then on the back, you'll see the learning targets, and you'll have a chance to write in the homework assignments. So let's get started on our first day of note-taking. Like I talked about in the other video, you'll have vocab for every section and practice problems that I'll expect you to write out. And remember, there are points attached to these. I'm not checking every notes every day, but I will spot check to make sure that you're following along. One thing I do want to add is that some lessons, like 1.2, are going to have the vocab section, and then they'll have a step-by-step and then practice problems. So every unit, every lesson will have vocab and practice problems. Sometimes there might be something in the middle. So let's get started with 1.1. If I look at this here, my first lesson, ooh, where's my clicker? My first lesson, maybe, there we go, is on variables and expressions. So it falls under that umbrella of numbers. But what I want to do is in each lesson, I'm going to tell you what skills we're working on. I don't want it to be a secret. Our Common Core skills that we're working on today are to interpret parts of an expression, such as terms, factors, and coefficients. We're going to use the structure of an expression to identify ways to rewrite it. And the practice that we're working on is we're going to model with mathematics. That means we're going to take those big ideas and model them. So first we have some vocabulary, and these first couple lessons are very vocab heavy. I want to make sure that you have a foundation of vocabulary so that you can accurately talk about these different mathematical ideas this year. Our vocab terms, the first one is an algebraic expression. An algebraic expression is an expression consisting of one or more numbers and variables along with one or more arithmetic operations. So you've seen this term before, but I still want you to write down the vocab term and the definition. I want you to build, basically, your own textbook here that you can use as a resource as you're working on your problems. So algebraic expression, you write the term and define it in your notes. Our next term is the word variable. A variable is a letter or other symbol used to represent an unspecified number or value. Again, you've seen this before. A variable is a letter, typically X in math, but it could be a smiley face, it could be the letter G, it could be a square. Term. Our next term is the word term. A term is a number, variable, or product or quotient of numbers and variables. It's that unit that we're talking about. If we're thinking about an expression, we could have a term 7. We could have a term n. We could have the term 7n, where we have the product of 7 and n. Which brings us to our next vocab word, which is factor. A factor is the quantity being multiplied in an expression. So if I'm thinking about the term 7n, 7 is a factor and n is a factor. Those two quantities are being multiplied together to give us a product. Our term is the product of those two factors. A product is the result obtained by multiplying two or more numbers or variables. So in your notes now, you can pause here, make sure that you write in all of these different vocab terms. And when you're ready, press play and we'll keep going with some more vocab today. 3 more vocab terms here. The first one is power. Power tells us the expression of the form x to the power of n. We would read it out loud as x to the nth power. In your notes, make sure you have the first half of this definition, but if you don't need the second half, you don't have to write that one down. Along with the term power, we have the word exponent. An exponent is a number that indicates how many times a number or expression is to be multiplied by itself. So if I think about my variable form here, x to the nth power tells me that I'm multiplying x by itself n number of times. Well, if I have those two terms, the last one that goes along with them is the base. When I'm talking about powers here, the number or variable that is raised to an exponent or raised to a power is called the base. An example with numbers would be if I have 2 to the 4th power, or 2 to the power of 4, I have a base of 2 and an exponent of 4, and I would call this entire term the power. 2 to the 4th tells me 2 times 2 times 2 times 2. All right, so we're done with our vocab now. In your notes, you should be moving on to practice problems. And remember, I want you to write out the practice problem and the steps to solve it. Well, in this case here, our practice problems, we're going to work on taking verbal expressions and turning them into algebraic expressions. Other way around. We're going to start with algebraic expressions and turn them into verbal expressions. Then we'll practice it the other way. If I look at this first expression here, I see many different ways that I can say this out loud. One way would be 16 times u to the power of 2 minus 3. I can go step by step and write out the words. So in my notes, this would look something like 16 times u to the power of 2 minus 3. But if I'm looking at this here, there are multiple ways. Instead of saying to the power of 2, I could have said u squared. Instead of saying minus 3, I could have said subtract 3. One thing with subtraction is that sometimes you can have it turn around. So another way to say this as a verbal expression would be 3 less than 16u squared. With subtraction and division, you need to be careful about your order, because sometimes it'll read in the order left to right, the way we read in English, and it'll work out. But sometimes subtraction gets tricky. I could say take 3 from 16u squared. Be careful with subtraction. Let's try again with a different algebraic expression. This one here, again, multiple ways. One way that I can take this algebraic expression and turn it into a verbal expression is I can say 1/2 a, that multiplication is implied, so I don't need to write it, or I could say 1/2 times a plus, or added to, 6 times b over 7. My verbal expression, I can use the word over, but I know as a mathematician that that really means division. So I could say 1/2 of a plus 6b over 7, 1/2 a plus 6b divided by 7, 1/2 a plus the quotient of 6b and 7. Many different ways. With your verbal expressions, there's often more than one correct answer. But now, the beautiful thing about math is that when we go the other direction, there's one answer. First practice problem here, when I'm taking my verbal expression and I want to turn it back into an algebraic expression. I want to write this using words, not using words. I want to write this using numbers, variables, and operations. So if I take 1 minus the quotient of r and 7. So I'm going to deal with the second half of that statement first. The quotient of r and 7. Well, quotient tells me division, so I have r over 7. Now, when I'm looking at this here, I see minus, so I know it's subtraction, so I want to think about it, but I don't want to trip myself up. Is this one telling me this or this? I have 1 minus r over 7, or r over 7 minus 1. Well, as soon as I say it out loud, I can see that this one is correct. I have 1 minus r over 7. This one would tell me 1 less than r over 7, or 1 subtracted from r over 7. So this one is the correct answer for C. One last practice problem with this idea here. The product of d and 3 increased by 4. Well, product tells me that I'm thinking about multiplication here. So d and 3 multiplied by each other, and I'm going to write it up here so we can actually see it. Increased by 4 tells me I'm going to add 4 to it. The only thing I would change about this one here is that in algebra, when I'm looking at d times 3, the way that I would typically write it is 3d plus 4. Both are correct. This one matches more directly to the verbal expression, but this would be the way that I would expect to see it in a math problem. And that brings us to the end of variables and expressions. So now it's time to think about the order of operations. Now this should not be something new to you. We've seen the order of operations probably every year in math since about 5th grade. But the first thing we're going to do is we're going to see what standards we're going to hit with this lesson. First, we are going to interpret complicated expressions by viewing one or more of their parts as a single entity. We are going to use the structure of an expression to identify ways to rewrite it, typo. And finally, we're going to work on that math practice of looking for and making use of structure. So, like always, we're going to start with some vocab here. First vocab term is evaluate. When I evaluate, I find the value of an expression. Now, when I'm talking about order of operations, this typically means that I'm going to get it simplified down to a single constant, to a single number. Order of operations, my next term here. The order of operations is a set of rules which are followed when evaluating an expression with more than one operation. An easy way to remember this is the acronym GEMDAS. Now, many of you know PEMDAS, where instead of the G there, you have a P. We'll talk about that in a minute. Either way is correct, but I like to use a G, and you'll see why on the next slide here. Why do we have an order of operations in math? Well, the reason we have it, and you'll see as you do some of the practice problems and when you get to the homework assignment, is that we want to make sure we get the same answer every time. Final vocab term for this section here is absolute value. This is one that I've seen students get tripped up on. The absolute value is the distance a number is from 0. The absolute value of a number is always positive. So the absolute value of 7 would be 7. The absolute value of -7 would be 7. I see students get mixed up. Absolute value does not mean the opposite. So if I have the absolute value of 7, it does not turn into -7. I want to remember that it's telling me the distance from 0. All right, so now we have a step-by-step. So in your notes, you should have your vocab first, and then the next thing you'll have is this little step-by-step. How do we solve the order of operations? Well, the first thing we do is we find the value of expressions inside grouping symbols, such as parentheses, absolute value bars, and fraction bars. This is why I use a G for GEMDAS instead of PEMDAS, because really, we're talking about grouping symbols. Oftentimes, that means we're dealing with parentheses, but it also means that we're talking about absolute value bars. If I'm thinking about a fraction, that vinculum, the line between the numerator and denominator, separates two different groups. I could also have braces, which look like wiggly parentheses. I could have brackets, which look like square-ish parentheses. I always want to deal with my grouping symbols first, which are not always parentheses. Next step is to find the value of all exponents. I need to simplify down any term with an exponent. Then I multiply and divide left to right. Not multiplication, then division. Multiplication and division happen at the same time, just like addition and subtraction. Your last step is to add and subtract left to right. Now, the way that I like to think of this is using a hopscotch pad. If you remember way back to your playground days, we're going to think about starting at the top of this hopscotch pad here, a little second grader. And the first thing when I jump as a second grader, I land with 1 foot into my grouping symbols. So I need to search and find all my grouping symbols in my expression and simplify them, evaluate them down to a single number. And then I hop with 1 foot onto my exponents. My next step is to search and simplify any exponents that I find. But after that, my next jump, I land with 2 feet. I land in multiplication and division at the same time. So I want to start the way I would read and read from left to right and find all of my multiplication and division. And then I jump again with 2 feet into the addition and subtraction land. I want to make sure that I'm solving from left to right. All right, well, let's practice. Let's think about how to evaluate each expression. Let me erase a little hopscotch here. Yeah, got letter C hanging out. All right, first expression, and so I want you to write this in your notes and follow along step by step. As we're doing these here, it's going to feel silly to show some of these steps because you can do them in your head. I know you can. But I want you to get in the practice of showing all of your work as you're going through this. So if I'm looking at this expression here, I need to think about GEMDAS, and I know my grouping symbols come first. So if I take a look at this here, I see my grouping symbols. I have parentheses with a -3 and a +7. So that gives me 4. I'm going to leave everything else the same. My next step, so from G, I jump into those exponents. Well, I don't have any exponents, so it's time to land with 2 feet into multiplication and division. So now I'm going to start at the left, and I'm going to move left to right, any multiplication and division. Well, I see this tells me multiplication. Subtraction stays the same. Oh, more multiplication. On to my last step, my addition and subtraction. Final answer, 22. Let's make it a little more challenging now. Oh, E and C pop up at the same time. We'll ignore C for now. We'll get there in a minute. My next practice problem here, I have 5 squared plus the absolute value of 3 minus 8 divided by 5. Again, I'm going to think about grouping symbols first, and in this case, my grouping symbol are absolute value bars. So the first thing I do, 3 minus 8, well, that gives me a -5. Still inside those absolute value bars, so I haven't quite simplified it yet. If I simplify here, the absolute value of -5 is +5. This part drops down, stays the same, and stays the same. I have 5 squared plus 5 divided by 5. Lots of 5s. Now I'm jumping into my next step, my exponents here. And I see an exponent, this tells me 5 times 5, which is 25, plus 5 divided by 5. On to the next hopscotch square, and I'm working on multiplication and division. Well, I see division, 5 divided by 5 is 1. 25 plus 1 gives me a final answer of 26. One last practice problem for this skill here. I want to look at -5 minus 3 quantity squared all over 6 minus 4 minus 50. So the first thing I need to do, I see my grouping symbol here. This fraction bar tells me that I have 2 separate groups. But we're going to deal with that top group first because I see more grouping symbols. I have 5 minus 3 quantity squared. So the thing I want to think about here is I've seen 2 answers. Many students get to this step here. And some students will simplify to 64, and some to -64. In this case here, that exponent tells me -8 times -8. Those parentheses tell me that it's everything inside. So negative times a negative is a positive. I get positive 64. To get -64, if I had -8 squared, this would tell me 8 squared, and then take the opposite. So this one would be equal to -64. But in this case here, we have positive 64. Everything else stays the same. My next step, I want to deal with the other grouping symbol. I've got 6 minus 4, so I get 64 over 2 minus 50. Last 2 operations, I see division and I see subtraction. So I'll do my division first, and I get 32. Take away 50. My final answer is -18. Order of operations. Should be pretty familiar at this point, but it's easy to get lost. Now we're going to move on to our last skill for this lesson here. We're going to talk about the properties of numbers. Now this one here has lots of notes to write, so if you have not been writing since March, you may want to take a break, stretch out your fingers for a second here. The skills that we are working on, and you do not need to write these skills in your notebook, we're going to be talking about how to interpret complicated expressions by viewing one or more of their parts as a single entity, and we're going to use the structure of an expression to identify ways to rewrite it. Very similar goals to our first lesson here. We're going to reason abstractly and quantitatively, and we're going to construct viable arguments and critique the reasonings of others. Lots of skills to work on, many of the same skills we worked on in the first 2. So, starting off, we have some vocab. First term is equivalent expressions. Equivalent expressions are expressions that have the same value or mathematical meaning for all replacement values of variables. These are things that are equal to each other. I can put 6x plus 2 is equivalent to 6x plus 2. If I put that equal sign, that tells me that they have the same value. Next term is the multiplicative inverse, which is also just known as the reciprocal. The multiplicative inverse is the number that when multiplied by a given number results in a product of 1. So that's the definition that you need to write. But to help you understand that, if I think about it, 1 over a is the multiplicative inverse of a because a times 1 over a equals 1. So, same thing. Either term is correct here. A proof is a logical argument used to validate a conjecture. So rather than thinking of proof like you might have talked about in your science class recently, in math we're talking about proofs as our arguments. And we'll talk more about that as we get into the year. So now we have lots of properties to go over, and you do not need to list them. You're clicking somehow. Pause. So these next couple slides are auto-advancing, but that's okay because I want to show you these different properties, but you do not need to list them in your notes. I want to make sure that you understand them because you will need to know them, but you don't need to write down all of these words here. So the first property is the multiplicative property of 0. And this is something you learned way back in elementary school, that for any number a times 0 is 0. 0 times a is 0. Anything times 0 is 0. Another property is the commutative property, so commuting things. So the order in which two numbers are added or multiplied does not change the sum or product. This is not true about subtraction or division. So commutative property of addition and multiplication. Same thing, we have the associative property of multiplication and addition. The way in which numbers are grouped when added or multiplied does not change their sum or product. These are things that you know and you maybe just don't remember the exact names of the properties. Next set are these properties of equality, so things that I can do to both sides of the equation to keep them equivalent. I have a reflexive property, that any quantity is equal to itself. The symmetric property, that a quantity equals a second quantity, then the second equals the first. Transitive property, so if one quantity equals a second quantity and the second quantity equals a third, then the first equals the third. So this transitive property tells me if A equals B, and I know B equals C, then I know that A equals C. Last is the substitution property, and this is the one that you will probably use the most, that a quantity may be substituted for its equal in any expression. So if I have 7 minus 2, I can substitute in 5, because those are equivalent. Next, there we go. Last, I have two identities. These identities tell me that the sum of any number and 0 is the number, and the multiplicative identity tells me that any number times 1 is itself. So, lots of identities and properties to understand, but you do not need to write all of those in your notes. We are going to move on to some practice problems now. And the first thing is I want to apply these properties of numbers. Now, your homework will not ask you to apply properties. I skipped that section because I don't think it's super essential to practice as a skill, but we're going to look at this just like we did with our order of operations. When I look at this, the first thing I need to do is I need to deal with my grouping symbol. Inside my grouping symbol, I see multiplication and subtraction, so I'm going to do multiplication first. Well, what I'm doing here, when I take that 4 times 2 and I replace it with an 8, that tells me that I am substituting. So my step, the property used in this step would be substitution. Next thing that I'll do, again, I'm still in that grouping symbol here. So I have 2 times 3 plus 8 minus 8. Again, I'm substituting. Next step, well, now I have both multiplication and addition. I've got to deal with my multiplication first. And I get 6. Again, I'm substituting. Last one here, I'm thinking about that last identity that I talked about. That last identity is the additive identity, which tells me that anything plus 0 is itself. Lots of work to get to a pretty simple answer here, but I wanted you to see what it looks like when I apply the properties of numbers. Let's move on, and we will practice evaluating expressions when I have different variables. So if I take these expressions, when A is 6, B is -2, and C is 1/3, my first expression I want to look at is B times A minus A times C. So what I'm going to do is I'm going to substitute in A is 6, B is -2, and C is 1/3. So B, I have -2 times A, which is 6, minus A, which is 6, times C, which is 1/3. And I have a dead pen already this year. Using substitution and my order of operations, I'm going to complete my multiplication from left to right. I have no grouping symbols, no exponents, on to multiplication and division. -2 times 6 gives me a -12. Subtraction, I'm going to leave alone. And I have 6 times 1/3, which gives me 2. Last step here when I combine these, this minus is really the same thing as plus a negative, so I get a final answer of -14. On to the next one. I have 5a minus b, quantity squared, plus 3c. Order of operations tells me, evaluating expressions, first thing I want to do is I want to plug in my values that I know. So I have 5 times a, which is 6, minus b, which is -2, all of that squared, plus 3 times my value of c, which is 1/3. So now my order of operations tells me that I want to look at this big grouping symbol here. Inside my grouping symbol, I see multiplication, so I'm going to multiply 5 times 6, which gives me 30, minus a -2. Well, minus a negative is really the same thing as adding a positive, so I get 30 plus 2, or 30 minus -2. And I'm going to leave this alone for now. Times. I almost made a mistake there when I forgot to carry over the fact that this is 1/3 times 3. There's that invisible multiplication. 1/3 times 3 is not the same thing as 3 and 1/3. So next step, inside my grouping symbol here, I have 32 squared plus 3 times 1/3. And jump up over here. 32 squared, well, I would grab a calculator for it. 32 squared gives me 1024. Plus 3 times 1/3. Oh. Now I have my multiplication and I have my addition. I get 1024 plus 1. Final answer is 1025. And that'll do it for all of this first lesson here. We have 3 separate sections with vocab to go through, but your job now is to go in and start your homework. So at the end of all of your notes, go to the next blank page, and at the top I want you to write assignment number 1, 1.1 through 1.3, and then write out the assignment. You can find the assignment on Teams, you can find it in the weekly email, or you can find it right here. You can pause, look for it here. Actually, I think it pops up on the screen next. It pops up on the screen next. So you can pause your screen so that you can write down the assignment. That assignment should be written at the top of the page where you start your homework, and it should also go onto your table of contents so that you can see it right next to task number 1. As you go through it, show all of your work and put a box around your final answer. For these first ones here, there's not a whole lot of work to show. And if you pause that, you saw lots of answers. What you'll need to do is you can also fold your page. So what I do when I'm solving these problems here is I take my page and I fold it across and make a crease down the middle so that I can get 2 columns worth of work, because I like to build my math vertically and it takes up a lot of space and I don't want to kill too many trees. So after you watch this video, you can go ahead and get started on your homework task. This first assignment will be due Monday by midnight, so you've got plenty of time to get going on it. And this video is quite long, so give yourself time. Make sure you're pausing to write in all of those vocab terms. Thanks, guys.